Hey everyone, welcome back to Drill Coding. This is part 4 of our top 10 Java interview question series. We are covering some core topics like marker interfaces, wait versus sleep, volatile, optional class, and many more, all with real world examples and line by line code explanations. If you are serious about Java interviews, let's dive right in. Let's begin with something simple and tricky. What is marker interface in Java? A marker interface is just an empty interface, no methods, no fields, and used to mark a class as having a special behavior. Now you might wonder what's the point of an empty interface? Well, marker interface tell the JVM or frameworks that a class has a special property. Example of marker interface include serializable, clonable, and remote. Let's look at this code. Here what's happening? Student class implements serializable interface, which is a marker interface. It tells Java that this object can be converted into a byte stream and saved or transferred. Let me give a real world example. Think of a suitcase with fragile sticker. The sticker doesn't do anything by itself, but it instructs the handler to treat the object differently. That's exactly what a marker interface does. Second question is difference between wait, sleep, and join. This question is all about thread management and it's super common in interviews. Let's break it down one by one. So wait comes from the object class. It's used inside synchronized blocks or methods and it releases the lock while waiting. So it's the example of wait. When we use object.wait, then thread will go to waiting state. Second one is sleep. So this comes from thread class. It simply pauses the thread for a specified time and it does not release any logs. When we use thread.sleep here, then it will pauses for 1 second. Third one is join. We use join when we want one thread to wait for another thread to finish. And this is also comes from thread class. So in this example, we are creating a thread here. And when we call join method, then main thread will wait until T finishes. So keep this table in mind. It's very useful for multi-threading rounds. Third question is what is the use of the volatile keyword? Volatile is used when multiple threads are accessing and modifying the same variable. Without volatile, a thread may cache the value locally and not see updates made by the other threads. Let's see this example. Flag is marked as volatile here. So every time a thread reads it, it gets the value from the main memory. Without volatile, one thread could keep seeing the old cached value and never exit the loop. So use volatile when you want to guarantee visibility of changes between threads and when you don't need full synchronization. Let's move on to the next one. What happens internally when we use the new keyword? This question tests how well you understand object creation in Java. So as you know, when we are creating object of any class, then we have to use new keyword here. So we are creating employee class object here with the help of this new keyword. Here's what happens under the hood. The employee class is loaded into the memory by the class loader and then space is allocated in the heap for the object and then fields are initialized, means variable are set to their default values, and after that constructor is called. Your constructor sets the custom value and then reference is assigned. Here reference to the object E is stored in the stack. So you are not only just calling a constructor, you are triggering multiple steps in the JVM. Let's move on to the next one. What is the optional class in Java 8? This feature introduced in Java 8. Optional helps us deal with null values safely and avoid those ugly null pointer exception. Instead of returning null, you return an optional wrapper. So in this example, optional.off nullable means we might get a non-null or null result, and if present checks if a value exists, and here get retrieves the value but only if it's present, and you can also use if present or else for cleaner code. With optional, you are forced to check for null, which leads to safer and cleaner code. Alright, let's take one of the most commonly asked question. What's the difference between method overloading and method overriding? These two concepts fall under polymorphism, but they work very differently. First one is method overloading. Overloading means you have multiple methods with the same name but different parameters, either in type, number, or order, and all these methods exist in the same class. So let me show you with a simple example. We have this mathUtil class which have these two methods. First method is int add. It takes two integers and return their sum. The second method is double add, which takes two double instead. So both methods have the same name here, add, but different parameter types, int and double. This is method overloading. So in method overloading, the compiler decides which method to call based on the arguments you passed. This is resolved at compile time, so we also call it static polymorphism. Now method overriding. Overriding happens when a child class defines a method with the same signature, that means same name and same parameters as in the parent class. So here animal is the parent class which has this method void sound that prints animal sound here, and dog class extends this animal class here, so it inherits the sound method, but dog wants to give its own implementation, so it overrides the method using override annotation here and giving its own implementation here. So at the runtime, Java decides to call the overridden method in the dog class. This is called runtime polymorphism. Make sure you practice both, they are easy to mix up in interviews. Let's talk about one of the most confusing yet important topics in Java interviews, comparable versus comparator. So both are used to sort objects, but they have some key differences. So we use comparable when we want to define a default sorting order inside the class. Let's look this example here. We have this student class here which implements comparable. The method compare to compares two students based on their marks. So if the current student's marks are more, it will return a positive number, which means this is greater. So when you call collections.sort, Java will use this logic. So this is natural sorting because it's built into the class. Let's talk about comparator. Comparator is used for custom sorting. If you want to sort by name or roll number or something else, then you can use comparator. So here this lambda compares two students by their name. You pass the comparator to collections.sort and it will sort accordingly. And this is helpful when you want multiple sorting strategies. So always remember, comparable is used inside the class and comparator is used outside the class. And method name of comparable is compare to, and method name of comparator is compare. And comparable is used for natural sorting order and comparator is used for custom order. So if you know how your object should be sorted by default, use comparable, and if you need flexibility, go for comparator. Eighth question is about default and static methods. So Java interfaces got a big upgrade in Java 8. And a lot of people still miss this question. Earlier interfaces were completely abstract. You couldn't write method bodies inside them, but Java 8 introduced default and static methods. So let's look at default method first. So in this example, the interface vehicle has a default method start, which means it has a method body. So this method can now be inherited by implementing classes without forcing them to implement it. And why is this useful? Suppose you have 100 classes implementing an interface. Now you want to add a new method. Without breaking all those classes, you add a default method. That's backward compatibility. Let's talk about static method. Square method here is marked as static. So it belongs to the interface itself. So you can call it with the help of this interface name, mathUtil.square. Square is the name of method here and giving the value inside the parameter of square. We don't have to create an object to call this method. We can call it directly by name of our interface. And remember, static method in interfaces are not inherited. So use default when you want to give a common implementation and use static for utility methods related to the interface. So with default and static method, Java 8 made interfaces much more powerful. Let's see next question. Ninth question is synchronized method versus synchronized block. This question usually comes up in any multi-threading interview. Let's say you have a multiple threads trying to access or update a shared resource like a counter, and you want to make sure only one thread can do it at a time. That's where synchronized comes in. In this synchronized method, the entire method increment is marked as synchronized here. That means only one thread can execute this method at a time on a given object, and it locks the entire object while method runs. And this is easy to use but might lock more than necessary, which could slow things down. And in synchronized block, this time only the block inside this method is synchronized. So we lock only this line here, and this gives you finer control and usually better performance. And you can also lock on any specific object, not just this. So use synchronized method when the entire method needs to be thread safe, and use synchronized block when only a part of your code is critical and to reduce lock time. And in real world applications, blocks are more preferred for better performance. Let's see next question. Last question is fail fast versus fail safe iterators. Fail fast iterators throw an exception if you modify the collection while iterating. We are looping through the list using for each loop, and inside the loop we modify the list by adding b. So the iterator detects this and throws a concurrent modification exception, so the iteration fails immediately. Hence the name fail fast. Collections like ArrayList HashMap uses this behavior, and fail-safe iterators don't throw an exception because they work on a clone of the collection. Here what's going on? This time we use copy on write ArrayList, which is a part of concurrent package. Internally it works on a copied version of the list, so modifying the list inside the loop doesn't affect the iterator. That's why it's safe, but it comes at the cost of performance. So always remember, fail-safe is slower than fail-fast and also safer than fail-fast. And fail-fast is faster but risky during updates. And knowing this difference shows you are ready for real-world concurrent development. This is all about today's video. And if you found this video helpful, don't forget to like, share and subscribe. And all the best for your interviews.